Hi there, in this engineering illustrated video, we will explore Ohm's law. Now, Ohm's law is, you can think of it as the pillar or the foundation of electricity because it explores three quantities or three variables. And basically, these three variables form the foundation of our modern understanding of electricity. And these variables are the voltage, the current, and the resistance. So we can think of the voltage and as a variable represented as V, or shortly we can call it as volts. And basically, and then we have the current, and the unit is amperes. And then finally, resistance R, and the unit is in ohms. We represent the unit in ohms. So basically, the law states that voltage is equal to the current multiplied by the resistance. And mathematically, we can write the equation like this. So V is equal to I times R. So what does it mean when we say so let's look at the what each because we said these are three fundamental quantities in electricity. So basically, you can think of it as the voltage as the pressure that pushes the charges through a circuit. So the higher the voltage, the bigger the pressure. So the next variable is the current, I. And the current is basically the speed or the flow rate of the electric charges that flow across the wire. So if you can think of it like the flow rate of water going through a pipe. So in electricity, the higher the current, the higher the flow rate. Just as if you open the tap water all the way, you're gonna get a high flow rate going through the pipe of water going through the pipe. So as the voltage increases, the current will also increase proportionally. Next, we have the resistance. This is our third variable in Ohm's law, and it kind of works opposite to the voltage, where it opposes the current flow. So the voltage, it strengthens the current, it makes it stronger, whereas the current, whereas the resistance, if you increase the resistance, you're gonna lower the current. So it works the opposite way, and we will see why in a bit. So Ohm's law, as we've seen that math using this equation, but visually we can also write it this way or draw it this way. So think of it like a triangle here where V is on the top, and I and R are in the bottom. So this is basically a shortcut of trying to trying to understand how we would calculate I, when we need to calculate I, and when we need to calculate the voltage, and when we need to calculate the resistance. So if you want to calculate V, we simply cover V right here and we look under. So under V is I and R, and we directly multiply. Whereas if we want to cover I, so if we cover I here, we're gonna see that V is over R, and there's a line between them, and this line represents the division. So if we cover I, we're going to see that V is divided by R. And likewise, if we cover R, if you want to figure out what R is, we cover R and we're going to see that V is over I. So this triangle, this Ohm's law triangle, basically it's for beginners, and it helps you understand when to uh, how these equations are derived, basically. And let's see a real world example now. So as we said, if we increase the voltage, we're gonna get, and assuming the resistance is constant, we're gonna get a higher current. And we can see that mathematically because looking at this equation for V, if R is constant and I is increased, V is gonna increase as well. So the current would increase when voltage increases. At the same time, if we increase R, let's say we increase R, and the current will decrease. So let's look at the current, assuming V is constant. So V is constant here, and R increases. So R is inversely proportional to I, meaning if R increases, if you plug in the math, if R increases, I is gonna decrease. So and it would make sense because when we say resistance, we are resisting the flow of the electric charges in the wire. So when we increase that resistance, we are essentially reducing the flow of electrons. And when we reduce the flow of electrons, so for simple electrical circuits like basically light, the luminosity will decrease. It's not gonna light up as strong as if the resistance or the voltage is increased. So let's and also if both V and R increase, the current would depend on how much it changes. So if V changes faster or increases faster than R, so basically you're gonna have V and R fighting each other to basically determine how much the current is. So if V is stronger than the increase of V is stronger than R, then the current will increase. And whereas if you increase the R, if the increase of the resistance is higher than the increase of voltage, then it's gonna reduce the current. So let's do some basic math here. So the when we plug in the numbers, it's pretty straightforward with the Ohm's law. So if we want to calculate if you want to calculate current, so in this example, there has to be at least two variables and one unknown variable. So in this case, we don't know what I is, but we know that the voltage is 12 volts and the resistance is 4 ohm. So uh, when we plug in the numbers with with I, we get 12 over 4, simply 3 ampere. And when we want to find the voltage, we just simply multiply, just as in this equation that we've seen earlier. V is equal to I times R. We plug in 2, which is the current, times 6, we get 12 volts. And finally, the resistance. Going back here, if we want to find the resistance, we divide the voltage by the current, and we get 6 ohms. And this is all the math that you need to calculate these three variables. So basically, once you know how to calculate voltage in I and R, you basically know how to use Ohm's law. So in Ohm's law in any typical circuit, you can think of it like this: when you control the voltage, you're gonna have to control it through the power supply. So let's say if you want to increase or raise the voltage, you're gonna have like a bigger battery bank. You increase the number of batteries because because the voltage is basically essentially connected to the power supply. And when you increase the voltage, you're gonna have a higher current, assuming the resistance is constant. So you'll have more current. And like as we mentioned earlier, if we keep the voltage constant and we increase the resistance, we're gonna have a lower current. So the current will decrease. Now these next points basically restate what we've said. So yeah, higher resistance in any circuit will reduce the current, and the current would adjust according to what the voltage and the resistance are adjusted to. So a higher V would cause a higher current, and a lower R, a higher R resistance will lower the current. Now, the next thing we need to know about Ohm's law are the units. So whenever we do the math, if you uh, look at the results that we obtained for the current, for example, the current, the unit for the number, the 3 amperes, is represented as A, whereas the symbol of the variable is I. So let's not confuse those two. So current as a variable is I, but when we quantify I, we represent the because it's we represent the number, the final result, as amperes using the letter A. And likewise for voltage, the unit for voltage is volts, and for resistance it's ohm, and it's represented using this symbol. That is a symbol called ohms. So the takeaway here, restating what we discussed. So voltage, you can think of it as the pressure, kind of like the pressure of electric charges. The higher the voltage, the bigger the pressure. Whereas the resistance is the works against the voltage. So the higher the resistance, the higher the opposition of the flow of the charges in the wire. And the current, basically it depends on what the voltage and the resistance is. So if we have a high resistance, we get a lower current, and if we have a high voltage, we'll get a higher current. Thank you for watching this engineering illustrated video. If you'd like to see more videos like these explaining engineering concepts using a visual approach, please like, subscribe, and share this video.